Hello guys, so today we are here to solve this sliding window maximum. In this problem, we are given an integer array nums and an integer k. So this integer array nums is just an array of integers, and then there is this k, and this k is used for doing window sliding, and we need to slide the window and get the maximum value in the window at each position. So see, this array is having in total, 8 elements. Okay, and k is 3. So first sliding window is this value. Then second sliding window is this value. Then third sliding window is this value. Then fourth sliding window is this value. And then fifth sliding window is this value. And then sixth sliding window is this value. So in this array, we have in total 8 elements, and the sliding window size is 3. So 8 minus 3 is 5. But since, this last is, starting from 8, 7, 6. So we are taking sixth, So it should be n minus k plus 1. Total sliding windows in this will be n minus k plus 1. And we have to, output the array of maximum values of each sliding window. How can we do this? So to do this, we'll be using deque. And deque is a, data structure which has the properties of queue as well as, stack. So deque is just, sort of double-ended queue. You can either add elements from the back of the deque or from the front of the deque. So it behaves like a, queue also. You can make it behave as queue also, and you can make it behave as a stack also. So it's more versatile than both queue and stack. And we will see that how are we going to use deque to solve this problem. So our approach will be, that every time at every sliding, window position, we will keep the largest of that window at that, as the first element of the deque. So once we are, here, we will be having the second element. Second element is the first element is zeroth index element, and second element is first. So first element will be in this sliding window. Okay. And when we are in this sliding window, then the largest is, fourth element. So the fourth element will be at the front of the deque. So that's what we have to maintain. And if you are able to maintain, we'll be easily be able to populate our result array. So first of all, we should declare one deque. Deque is an integer. Deque is equal to new array deque. Okay. And we can also say that the size of the deque is nums dot length minus k plus 1. Okay. And then we'll have to declare one result array. So result array will be like this. Nums dot length minus k plus 1. Because from the 6th, 7th, 8th, so 6th index element is the last, is the last window for k is equal to 3. Okay. So now the situation is clear. Now we'll start with our loop. In this loop, we'll take the 0th element, then the loop will be going till k. So right now we are just, first window, we are taking care of the first window. And in this, what we will do, first of all, we will add deque dot add last of I. But before that, we want to check while deque dot is empty. So it's not empty. First of all, we have to put a check. And deque dot peak last is less than the current nums I. Okay. If it is like that, then we will be doing deque dot remove last like this. Okay. So we will be taking a look at the last element. Okay. If it is less than the current, incoming element in the, ith position, then we'll be removing that, and we will keep on removing that last element as long as it is smaller than the current element. And after that, we'll be adding this index of that current element. Okay. Okay. So here also we can do result of 0 is equal to deque dot peak, and this will be nums of deque dot peak like this. And then again we will use our this loop, int I is equal to 1, I less than nums dot length minus k plus 1, okay, plus I. So now we are starting from I is equal to 1. So our window will be 1 plus k minus 1. So our window dimensions will be I plus k minus 1. So this element will be the incoming element. The element at I plus k minus 1 will be the incoming element, and the element at index lower than I will be the outgoing element like this. Okay. So to check the outgoing element, what we'll do that we'll set one, deque dot is empty. First of all, we will need to check this. So if deque is not empty, then only we'll be doing this. Okay. And deque dot peak, just peak. Deque dot peak is less than I. Deque dot pole will remove the first element. Else again, what we will do that if deque dot is empty, so we are putting this check so that we are not removing, we are not making the deque, removing the last, making the deque empty. We are not, crossing the boundary of that. And again, then we will be checking that peak last. So last is the last element in the deque, and we'll be checking it with nums of I plus k minus 1. okay, with this element, and then we'll do deque dot remove last simply, okay. And after this, what we will do, that deque dot add num I plus a minus 1. So this operation is definitely required. And then here what we'll do, that the result of I is equal to nums of deque dot peak. Okay. And then at the end we'll be returning the deque. No, result array. That's what we are supposed to return. Okay. So let's run this. Perfect. So there is an error. Error is that it should be 7 2, then it should be 7 and 4 should be returned, but it's returning 2. How come? Okay, so the mistake is happening at the first. So while deck is not empty, deck of peak last is less than terms of I. Okay, so we do nums of deck of last. Same thing we need to do over here also. Okay, perfect. So I hope with this solution is clear to one and all. If you have any doubt, please post it in the comments and I'll definitely clarify that. But for the benefit of everybody, I'm going to, I'm going to, run through this solution once more. See, we are given an int array nums and we are also given a integer value k. We need to find that from all the different windows that can be formed on the nums array of size k, we need to find the maximum of all those windows and put it in the result array and return it back. So in a given nums array, how many windows are possible of size k? They are possible of the length of that nums array minus k. Okay, but if you do just minus k, then you're missing one window, so you need to add that. Okay, nums dot length minus k plus 1. So this is the total number of windows that are possible on a nums array. And then you first find out, okay, which one from 0 to k is the largest element, and that element we are saving in our, that element's index we are saving in our deck. And that's how we are going through this. this loop at line number 6. So first of all, we are checking, we are adding, the last adding elements to the last of the deck, and then deck is not empty, then nums of deck, peak last is less than nums of I. So what we are doing that, the nums value of the last element in the deck, if it is less than the current element, current incoming element, then we are keep on removing the last element. Okay. So that's it. This is what we are doing. And here at line number 17, the for loop, in this for loop, we are starting from I is equal to 1. So we are, 1 is the lower bound of our window, and with I is equal to 1, the last element of that window of size k will be I plus k minus 1. So this is I plus k minus 1 is the incoming element, and this is what we are comparing with the, at the end of the index value, that is at the end of the deck. If it is the incoming element is greater than that, then we are removing the last element, and we keep on removing the last element. So our intention in this removal is that the greatest element should be coming on top, and the something which is less than that greatest, it should be, coming after it. So this deck is, keeping things in a manner so that the element at the front of the deck is the largest in the window, and that's how we are trying to solve this problem. So if you have any other doubt, please let me know, and I'll definitely try to answer those doubts. Thanks a lot. Happy coding. Bye.